Okay, hi everyone. We're going to go ahead and do a speed run through our second review, so you guys have a copy of this. Now, question number 1, here we go. Asks to solve for x pretty much, okay? Solve for x. It's our only variable here, and we want to make sure this goes to 0. And now this is really fast, because what value would make positive 7 cancel out to become 0? Well, that's negative 7. What value would make negative 9 cancel out to become 0? That's positive 9. So x is negative 7 and 9. That's why we factor. We factor because it's a fast way for us to solve for zeros. Super duper fast. The second question here, this trick only works for solving for 0, okay? This trick only works for solving for 0 because this next one here is not solving for 0. So we're going to have to rewrite this. So to rewrite this, because how can you predict two numbers to make them multiply to become negative 33? It's like you guessing a number and someone else guessing a number and it's supposed to all of a sudden become 33? No, the hint is that if it's become 0, it's because what's 0 times anything? That's going to be 0. So that means we can solve each of these separately for 0. That's how we end up with our answers, negative 7 and 9. Okay, but if we understand this concept here, we can just do that with some quick plugins. Now the next question is, we're not solving for 0 here, so darn it. So we actually have to multiply it out. P squared, P times P is P squared, minus 14 times P is 14P, and then equals to negative 33. I'm going to move that over, so I'm going to say plus 33 equals to 0. Now, is this factorable? And that's what you always want to quickly check. Is this factorable? So two numbers that multiply to become, Brittany, you can ask me later. I'll tell you later. Okay, so it's 3 times 11. And would you agree 3 times 11 is 33? Yes. But 3 plus 11 is also 14. Yeah. So it means this is factorable for us. We have to make sure we just set it up correctly. P times P is P squared. We said 3 and 11 are perfect numbers. Now, how do we end up with a negative 14 and a positive 33? They're both going to be negative, because negative and negative is a positive, and negative 3 and negative 11 and negative 14. Yes, it's that fast. Too fast, Mr. Co. But this is a review. 3 minus 3 and 11 minus 11. That's our p-values. So if p was 11, great, and if p was 3, we'd be winners also. Now, you might not believe me, but let's try it. If I plug in 3 here, 3 times 3 minus, darn it, I'm not sure why I did that. 3 times 3 minus 14, right? I just plugged in the 3. Would that give us negative 33? Well, it actually would. Wow, who would ever have guessed that 3 would have been an answer? And if I plugged in 11 minus 14 is negative 11 times, 11 times, this is a 3 here, that's negative 33. Wow, amazing. Amazing. Okay, factor the following quadratic. This one's pretty easy because there's only 2 rather than 3. So what is a common value I see that's in this problem? I see t squared minus 5t. So I see a common t. So we factor out the t. So we're left with t squared minus, not t squared. I'm half asleep still. T minus 5 equals to 0. I want you guys to make sure this is true. T times t is back to t squared, and t times 5 is back to 5t. Yep. So when we factor it, this allows us to solve for zeros. And this is what we call the zero product property. If I can make you go to 0 and you go to 0, well, those are answers. And if we double check, if I plug in 0 here and 0 here, we do have 0. And if I plug in 5 and 5, 25 minus 25 is 0. Yeah, that's a win. Okay, if you're watching this over YouTube, you can just pause anytime you want. Now, this problem, whenever you see a trinomial and they're asking us to factor or doing any of this stuff, remember the trick is to, if it's a level 1 problem, go ahead and take a look at the last value, 40. What numbers make up 40? 1, 40, 2, 20, 4, 10, 5, nope, 5, yes, 5 and 8, okay? 6, 7, those aren't divisible into 40. And then you ask yourself, which of these add up to become 13? Does 5 and 8 add up to 13? Does 4 and 10? Does 2 and 20? Does 1 and 40? And hopefully you've done this enough time that you've actually built a mechanism in your brain that you're always checking which factors work. So 5 plus 8 is 13. Wow, we found out the pair that works. So the pair that works for us is going to be x times x. That's how we get x squared in the front. What numbers do we use to get 40 in the back? We had 4 different options here, but we know our winner is 5 and 8. Now the hard part here is deciding what type of sign goes in it. We said if it's a plus plus, that means it's going to be automatically plus plus, because a positive 5 times positive 8 is a positive 40. Yes, that's a win. And a 5x, positive 5x plus a positive 8x is 13x. Now, if you need some extra help for factoring, please come talk to me. I'll teach you guys my skills of factoring, or just go back and watch the YouTube video where I try to teach factoring to you guys. There are many different ways of doing factoring, and people have come up with something called an Xbox. Some people just list the values on the side. But go ahead and watch my version. I like my version. That's me, personally. Numbers that make up 3, it's 1 and 3. And do they subtract out to become 2? They do. So I'm going to go ahead and set up my factors, C, 1, and 3. And I do this, even though you can guess what the answers are, but I always do it so I don't mess up on my signs. Now, since we say 2 is negative, so it's going to be positive 1C minus 3C. So we need more negatives on the C. So I'm going to take the negative 3 and a positive 1. Solving for 0, what number would make each of these factors go to 0? You could write this out. That's what you could do. But let me go ahead and finish this. Can you just tell me what number makes these go to 0? That'll save us so much time. Negative 1 and 3. So to show work here, I expect you guys to show me the factored form, if that's what you did, or if you want to use quadratic form, that's also okay, but you need to show me the work. You can't just say, oh, I did it in my brain. If you do that, I will give you a 0 on this problem. Unfortunately, I asked you guys to show work. If you guys also need help, they also have videos and a written example here. So make sure you do take advantage of it. And if you want to just practice 1,000 times, after you submit this question, you can try another one. There are 19 different versions of this question here. So there's plenty of practice problems that you can do. Now, is this a skill that's important? Yeah, that's what we go over in Algebra 1 and Algebra 2. Okay, next one is solve the equation. Now, x squared problems, we always want to try writing them on the same side. Equals 0, and then we can see if this is factorable. Always check if it's factorable first before you try any other method. I can factor 1 times 2 is 2. Hey, 1 plus 2 is 3. Yes, this is factorable. Oh my gosh, this is the easiest test in the world. X is equal to negative 1 and negative 2 because we're making them go to 0, right? Okay, next question, we're going to go ahead and solve the equation. Oh my gosh, this is level 3 if this is factorable at all. So I don't know if it's factorable, so I'm going to go ahead and just try it. 1 and 10, 2 and 5, these are the only ways of making the number 10, and 1 and 6 and 2 and 3, only numbers I'm making 6. Now, do any of these guys subtract out to become 11? I think if I say 5 times 3 is 15, and 2 times 2 is 4, if I subtract them out, they do become 11, don't they? So this is factorable. So since it's factorable, let's break it up. We said we're going to use not 1 and 10, we're going to use 2 and 5. 2x times 5x is 10x. And then, do I put the 2 here or the 3 here? Which one do I put? And the way I did this is I taught you guys to draw a little frog face here. Because the 2 is going to multiply the back. That's our outer versus our inner. Our outer value is 2 times, we said 2 times 2 to end up with the 4. So 3 has to go on the other side. So we got all our number placements done. 2 times 2 is 4. 3 times 5 is 15. That's how we're going to end up with 11. But we need to subtract, right? So we have a positive 15 and a negative 4. So positive 3 and 5 and negative 2 and 2. Okay, once we're done with that, let's make them go to 0 now. Mental math, you can say 2x plus 3 equals 0. So in your brain, minus the 3, divide the 2. X equals to negative 3 over 2. In your head, 5x minus 2 equals 0. Get rid of the 2, get rid of the 5. So we're going to add the 2 and then divide the 5. So these are 2 answers. Seems very quick, but you guys can be this quick at this. This is no more than an advanced multiplication problem. Okay, number 8. Find all the solutions for the real problem. This one's already set up. This is similar to a completed the square problem. Okay, complete the square problem. And what we're doing is we can just solve for t. So to solve for t, we're going to get rid of a bunch of stuff here. We're going to get rid of the 26, the squared, the 5, and then the 6. So we have 1, 2, 3, 4 steps that we're going to do all in one step. Okay, so let's go ahead and do it. We're going to say 14 is on the right side, and we're going to minus, so we're going to plus 26 to it, right? The opposite of minus 26 is plus 26. After that, we take a square root to get rid of the square, so plus and minus. Then we get rid of a minus 5, which is a plus 5. And the last step is to, what's opposite of multiply by 6? We divide everyone by 6. And this looks like the quadratic formula. 5 plus and minus the square root of, that's 30, that's 40, square root of 40, over 6. So you have to do the square root. Make sure you do show the work. 40 is 2, and 20 is 2, and divide 20 by 2 is 10, and divide by 10 by 2 is 5. We do have a pair of 2's. 5 plus and minus 2 square root of left over 5 and 2 become 10, all over 6. You cannot reduce this. So on the test, I think they're going to have to ask you to ask 5 plus 2 square root of 10 over 6, and 5 minus 2 square root of 10 over 6. Okay, I'm going to go ahead and just double check that. This question was number, I think 8, right? Okay, take a look at the answer. Yeah, they just separated. And if you kept them as one fraction or not, they would have accepted them both. But they want you to write them out separately, okay? Okay, the next question is, go ahead and write the quadratic in a factored form. Okay, let's go to factor. Two numbers that make up 21. 1, 21, 3, and 7. Does 3 and 7 add up to become 10? Do they add up to become 10? They do, so we have our values already that we know we have to use. We have to use 3 and 7, and then they're both going to be minus, because negative times negative is a positive 21, and negative 3 and negative 7 is negative 10. If the square root is negative, that means it's imaginary, so we've been working on that. So if the square root was negative, we would write I, imaginary square root of 10. Okay, great question. Sorry I missed that. Okay, so if it was negative, you would write an imaginary I there. Okay, and that's actually the second part of this review, imaginary numbers. Now the second part is complete the square and write in vertex form. All right, since this is a level 1 problem, which specifically this was, we're going to go ahead and complete the square. We complete the square by level 1 is divide by 2. We always divide the b value by 2 is negative 5. Now what's the perfect c value I wish I had? I wish I had 25, right? X squared minus 10x plus 25. That's my perfect square here. If I add 25, we minus 25 to it. So we're left with negative 25 plus 21 is negative 4. That's our vertex form. The cool part is now we can answer the second question. What's the vertex of the parabola? It's 5 comma negative 4. Right, we said our vertex form is y is equal to a x minus h squared plus k. So h is inside the parentheses and k is outside. What's the y-intercept? Okay, y-intercept is when x is 0. So we can plug in x is 0 anywhere you want. You can plug in x is 0 here, or x is 0 here, or x is 0 in the initial problem. And if I do plug in 0, the 0, 0, we're left with y is 21. Because the y-intercept is when x is 0, what's the y value? So just plug in x, and we end up with 21. The x-intercepts are when the graph goes to 0, set that equals 0. Our x-intercepts are at, so I think they tell you the 1 points on the graph. So our x-intercepts is when y is 0, x is 3, and when y is 0, the other x is going to be positive 7. Those are our intercepts. Okay, so we had these problems before in our last test, okay? so they shouldn't be new. Find the last term in the trinomial to make it a perfect square. What would make this into a perfect square? A perfect square problem is x squared plus 4x plus 4, x squared plus 6x plus 9, x squared plus 8x plus 16. The trick is you take the middle, divide by 2, and then we square it. Take the middle, divide by 2, and then we square it. Take the middle, divide by 2, and then we square it. So we take the middle, divide by 2 is 3, and we square 3 is 3 squared is 9. Now write the perfect square. If I gave you x squared plus 6x plus 9, well, this perfect square was a x plus 3. And that's what we do when we complete the square. We say divide by 2 and bubble up. Find the last term to make the trinomial into a perfect square. So same question as before, except this one is a fraction. If I divide by 2 though, and square it, what's 1/2 squared? It's going to be 1 over 4. 1/2 times 1/2 is 1 over 4. And write the trinomial as a binomial squared. Reduce the fractions, but not they want decimals. So when I divide it by 2, it's x plus 1 over 2 squared. If you remember, we half it. So it's x plus 1 over 2 squared, and then we square it to get our c. Again, there's a video here if you guys want to watch, as well as you guys can go back and watch my videos. Let me give you another one. If I say x squared plus 3x plus blank, well, what would the c value be? It'll be 3 divided by 2 is, that's my perfect square. And the perfect c value I wish I had, what 3 and 2 times 2 is 9 over 4. Okay, number 12, find all the zeros of the function. Always we want to try to first is complete the square. No, sorry, to factor, but I can't factor 19, that's 1 and 19. And no way does that give you 4. Right, that's not 4. So we know factoring is not going to work. So instead, let's go ahead and complete the square. This is level 2, because they want us to solve for it. So here we go. We're going to say r squared plus 4r minus 19. Let's go ahead and complete the square. R plus 2 squared. Do you have to complete the square? No, you can use quadratic formula. But when I complete the square, I'm going to end up with a super fast answer, negative 23 equals to 0. Divide by 2, 4 squared, 2 squared is 4, 4 minus 4, yep, 23. And now our answer is going to be r is equal to, get rid of the 23, is positive 23. Get rid of the squared, which is square root. Get rid of a plus 2 is minus 2, plus and minus. That's your answer. Negative 2 plus square root of 23, and negative 2 minus square root of 23. Now what if I want to use quadratic formula? 100% okay. X equals to negative b plus and minus square root of b squared minus 4ac. 4 times 1 times 19 is 40, 70, that's a positive. 4 times 40, 36, 76, all over 2a, which is just 2. Okay, and I did half of the stuff in my head, right? 4 squared is 16. 4 times 1 times 19 is 76, because 4 times 10 is 40. 4 times 9 is 36. 40 plus 36 is 76. Negative 4 plus and minus square root of 80, what is that, 92? 92, all over 2. Now I have to do the square root of 92, which I can do. Divide by 2 is 46, I think. Yeah, 46. Divide by 2 is 23. And then we have a pair, no more pairs, so it's negative 4 plus and minus 2 square root of 23 over 2. Then we divide everyone by 2. Negative 2 plus and minus square root of 23. Oh my gosh, it's the same answer, but with so many more steps. Now, again, if it's a odd value or an even number, I think completing the square is so much faster to solve for this. But of course, it takes practice to get good at it. But that's me personally. But if I'm trying to save seconds on the clock, I would do completing the square, because I'm actually pretty darn good at it now. Okay, they want us to go ahead and solve for this one also. So I'm going to do completing the square. You can do quadratic formula if you want, But I can help you set up quadratic formula. X equals to negative b plus or minus square root of b squared minus 4ac. 4 times 1 times 18 is 40. 40 plus 32 is 72. So plus 72 all over 2a, which is just 1. Okay? But I'm going to do the quadratic. I'm going to do completing the square. And let's see if it's going to be a little less brain power for me. But that's just me, okay? We're going to divide by, darn it, divide by 2. It's going to be x plus 5 over 2. Mr. Ko, I hate fractions. I don't care. The square of 5 is 25. That was so hard. Square of 2 is 4. Add and then subtract 25 over 4. So we're going to combine 18 to become a 4. 4 times 18 is 40. We did it over here. It's actually 72. So we're going to say minus 72 over 4. Combine those together, we end up with 97. Yeah, 97. So minus 97 over 4 equals 0. Let's go ahead and kick stuff over. 97 over 4 square root plus and minus negative 5 over 2. So it's going to actually be very similar to what we have over here. Square root of 97, I can't do it. And all over 2, because the square root of 4 is just 2. So common denominator. Turns out that's actually what we get up over here. Negative 5 plus or minus square root of 97 all over 2. Okay, so I would say fractions are on par, if not, in my mind, slightly faster than quadratic formula. Okay, we're going to get into our complex root section. Sorry, not complex roots, complex numbers. So a complex number is a number with an imaginary part to it. This is my real, and this is my imaginary, and this is what we call a complex number. Things are complex. Complex number. Okay, that's just on the side. Now, what's the square root of 100? Now, we can't take square roots of negative, so you first have to take out. Yeah, so you'll get credit for these, for the reviews, yes. You get 10 points each. So square root of a negative, we can't. So we take out the imaginary first, and then we can take a square root of 100, which is 10i. Write the constant in the front and the variable in the back. No, it's fine. If you guys get something like 80% or above, 75% above, I'm going to give you the full 10 credits. Okay, I'll give you the full 10 credits. I can take a look at yours specifically later to see where the mistake is, okay? All right, this next question is, hey, can I add 64 and 49 even though they're both square roots? No, we have to first rewrite it. The square root of a negative is I square root of 64 minus I square root of 49. Now I can take a square root of 64, which is 8i minus 7i. Now I can combine them to become just I. So you have to change them to imaginary numbers first, and then we can combine it. Because you cannot do any operations on imaginary things. Like you can't feed tea to your imaginary friend. You can't take your imaginary friend to the theme park. And people make them into stuffed animals, and then they can take them around. This question here is we combine like terms together and like terms together. So 2 minus 7 is negative 5. And negative 2 plus 5 is positive 3i. And they want you to just write what the real number is and the b value, what the real number is. That's all they want you to write here. And many of you guys figured that out. Great job. This expression here is you have to first get rid of the imaginary number. Then you can take the square root of 144, which is 12. So 12, so negative 9 times 12i. 9 times 12 is 90 plus 18. That's going to be 108. You always have to take the imaginary out first. Now, the next problem is find the conjugate. And I actually wrote the conjugate. I edited the code so we could look at the conjugate. So when I'm multiplying negative 2 minus 5i times negative 2 plus 5i, we said there's a trick here. When I'm multiplying the conjugate, it actually becomes, though it looks ugly, it looks terrible, we just have to say, what's negative 2 times negative 2? That's going to be positive 4. And then we see minus 5i times 5i. That's 25i squared, negative 25 I squared. What about the middle parts? What about the middle parts? Well, they always cancel out. This is going to be negative 2 times 5 is negative 10i, and negative 5 times negative 2 is positive 10i. And look, they always cancel out. Conjugates, the middle terms always cancel out, and we're left with 4 plus 25. How did I do that? Because, sorry, this is I squared. I squared becomes a negative, negative, and negative become a positive. So our answer is 29. So is there any imaginary parts? No, it's actually going to be 0 and 29. There are 0 imaginary parts left over. So again, let me give you another easy version. 1 plus 2i times its conjugate 1 minus 2i. 1 times 1 is 1. 2 times 2 is 4, negative 4i squared. Negative 1 becomes a 4. 1 plus 4 is 5. Okay. Whenever you do conjugates, you just look at the front and the back. That's how fast it could be. Now, the next questions are super dumb. They're pretty easy. Classify the number set that describes the number negative 7. Is negative 7 a real number, imaginary number, or complex number? This is a real number. If I wrote negative 7i, this would be imaginary. But if I wrote negative 7 plus 7i, that's complex. Remember, a complex is a imaginary number and a real number together. That's why it's a little complex. How's your relationship? Well, it's complex. It's not imaginary and it's not real. We just have parts of both. Number 20, just to repeat from our last problems, I can't take a square root unless if it's we take the negative out of the square root first, because we see negative 16 inside the square root. So we see I squared of 16 is 4i, because the square root of 16 is now 4. Now, we start some multiplication problems. 6i times 11i, we multiply the real numbers together, and then we multiply the imaginary. That's 66i squared. We have a rule for I squared. I squared is always negative 1, so that's negative 66. Super easy, okay? Super easy. Just remember the rules. The last question here is, again, we're going to do the conjugate. This time I'm going to ask you to find a conjugate. What's the conjugate of 6 plus 4i? The conjugate is 6 minus 4i. That's what the conjugate is. Oh, darn it. I didn't include one of the I questions. Shoot. I thought I had it. There's one of these questions that says I to the 50th questions. Oh my goodness, I thought I had it. Okay, so I'm just going to talk about it in this video, and then I'm not sure. I don't think they'll let me add questions to it anymore. Darn it. Oh my gosh, I thought I had it. Gosh. I don't know what happened. Okay, so it's going to be 6 times 6 is 36 minus 16i squared. Don't even bother with middle terms. Conjugates don't bother with middle terms. You can even not bother with this line. You could just write 36 plus 16. And we're left with the answer is 52. Yeah, that's it. Oh my goodness, what happened to that question? All right. Okay, that's it. Oh, you know what? I might as well do the question right now. I'm going to make it up, okay? So there will be questions on the test that have this idea. What is the I of I cubed? What is the I of 5? What is the I to the, let's say, 10th power? What is I to the 100th power? What is I to the 52 power? What's I to the 27th power? What is I to the 37th power? What is I to the 21 power? What is I to the 19th power? Okay, so we're going to do these all quickly. I to the third power is, we said it's I squared times I, right? I squared is negative 1, which is negative I. That's what I cubed is. Every power of I has to be rewritten either to a real number or to a single I value. I to the 5th power, we know I to the 4th is 1. So that's 1 times I. This is just I. After every 4 i's, remember, we always reset. Okay, I to 100. If it's divisible by 4, okay, that means that's just 1. Is 2 divisible by 4? Yes, it is. So this is just 1. Is 27 divisible by 4? Nope. It is I to the 24, times I to the 3. So this is 1 times negative I. This is negative I. We can almost say, like we mentioned before, we have a I clock. It's I squared, I cubed, and then I to the 4th. Depending on how many i's we have, we just keep going around the clock, and the answers just keep repeating themselves. Negative 1, negative I, or 1, or back to I. So if I have 5 i's, I go 1i, 2i, 3i, 4i, 5i. I'm back to I. If I have 3 i's, 1i, 2i, 3 i's, negative I. If I have 100 i's, it would just end up going around the circle. You would stop at back to 1. 37. Well, that isn't divide by 4 36 plus 1. So answer is just I. We have 1 extra I. 21, that's really close. 20 plus 1, that's just I, because we have 1 extra I. 19, oh, that's 16 plus 3. So that's negative I. Okay. For this problem, just write out the leftover I, that's all. So if you have I cubed left over, make sure you just write I cubed and then write negative I. That's the fastest way, I think. And that's all the work you need. Hey, that's it.